Okay, I'm back, and I've written our rules of exponents down for us to make sure we remember. So let's take a look at the first one. Now, I'm going to say some important points, so please make certain you write these points as well as the rules, okay? First point I'm going to make on number 1 is that notice the bases are exactly the same. When the bases are the same and you're multiplying them, that means you get to add those exponents together. Okay? X to the second times x to the third. 2x is here. 3x is there. 2x's, 3x's, that gives you 5x's, right? Okay. But what happens if your exponents are rational? What happens if one exponent was a 2/3 and you're supposed to add it to a 4/5? What do you got to do? Common denominator. Good? Okay. Number 2. I kind of have a two-parter here on number 2. Now I'm dividing, but I'm dividing the exact same bases. Are you with me? And remember, when you divide the exact same bases, you get to subtract, don't you? Now, here's the deal. I broke it into 2 parts. Why? Because if the top exponent happens to be larger, then my brain always wants to take the larger number minus the smaller number. And since the top, the numerator, has more x's, that means that the result of that subtraction problem is going to be in the numerator because it had more x's. So all the leftovers are going to be on the top. Whereas, if your power on the bottom was larger, then the leftovers are going to be in the denominator because that's where most of the x's were. So that's why this answer has it on the bottom. And I have b minus a, the denominator minus the numerator. Cool? Okay, mind you, all of these are refreshers. I may put a little bit of a different outlook on some of these rules than maybe you've seen in the past, but you've seen all of these. So by the way, what happens if your exponents are fractions? And now instead of adding them, like on number 1, the first rule, now you're going to subtract them. Yeah, you're going to have to get a common denominator, aren't you? So for numbers 1 and 2, you need that common denominator. If you add the exponents or subtract the exponents, you're going to need to make certain you have a common denominator so you can deal with it. Right? Okay. Look at number 3. I have got x to the a times y to the b in parentheses. And outside this parentheses is another exponent called c. Remember, any number outside the parentheses you get to distribute. Agreed? But in this case, you can only distribute an exponent to another exponent, which is why the result looks like this. But what happens if those exponents are fractions? How do you multiply fractions? Yeah, no common denominator needed. You multiply straight across, reduce when you can. Right? Okay, number 4 is almost like number 3, except instead of multiplication between the x and the y, I have got division. So, again, a number outside parentheses, what do you do with it? Yeah, exponents get distributed to other exponents, which is why the result looks like this. So, quick sidetrack on numbers 3 and 4. Are the x and the y, are they the same base? Good, they're not. Since they're not the same, could I add the a and the b together? Nope, you can't, which is why numbers 3 and number 4, since the bases aren't the same, you can't add or subtract these b's, these a's and b's, which means it goes straight to the distribution problem. Okay? Making certain you remember that. Because in order to add exponents or subtract them, your bases need to be the same. And since they are not, then you go straight into distributing the outside exponent with the inside exponents. So really 3 and 4 are straight multiplication problems between exponents. no common denominator needed. Numbers 1 and 2, common denominator needed. Why? Because you're adding and subtracting exponents. And you're adding and subtracting fractions. 3 and 4, no common denominator needed because you're just multiplying fractions. Good? Okay. Number 5. Now, I put number 5 down as a refresher, right? Because we did a problem just a few minutes ago that involved negative exponents. So as a refresher, if your base has a negative exponent and your base is in the numerator, it's going to drop to the denominator. However, if your base is already in the denominator with a negative exponent, it gets moved to the numerator. Cool? Good. And you're like, where'd the 1 go? Well, 1 times anything is just itself. That's why you don't see a 1. Now, number 6. Some of you remember, x to the 0 power is always 1. And some of you are like, you know, I've heard that. Why? Okay, I promise we didn't pull that out of the thin blue air. Okay? This power of 0 means you have how many x's? You don't have any x's left in your answer. So I shouldn't find any x's left in my answer at all. So there's no x's in the answer because there's 0 power on the x, no x's. However, there's something hanging out front going, I'm still here. Do you remember me? See that 1? That's why the answer is 1. The 1 in front is going to be what remains, what's left there. If I have no x's, then there are no x's in the answer. There's only that imaginary 1 hanging out front that will be the result. Good? Okay, so we're going to put these rules of exponents into practice, and your exponents are going to be rational exponents, which means you need to remember how to add and subtract fractions and how to multiply fractions as well. Hang in there. I'll be back with some examples. All right, so let's look at some examples. The directions simply say simplify. So, number 1, they want us to simplify the 6th root of a to the 3rd. Now, we've looked at these before, and we realize there's 3 a's under there, but according to this index, I need 6 of a kind to take 1 out. Well, clearly I don't have 6 of a kind, right? So there's no way I can take an a out. Do you agree? However, I can still simplify this. And the way I can simplify this is by rewriting this. Take it out of its radical form and put it into the rational exponent form. So what's my base? A. Good. So the power is what? 3. The root is what? 6. So remember, you can write this to the 3/6 exponent. The 3 is the power, the 6 was the root, correct? And I can simplify 3/6, can't I? What does it simplify to? Yeah, it simplifies to 1/2. So, is there anything more I can do? No. Now, the directions may say, leave it as a rational exponent, and there it is. But if it says put it back as a radical, then that means you're going to have the 2nd root of a to the power of 1. And we're not going to write power of 1 because anything to the first power is itself. By the way, more than likely, the homework program you're working with isn't going to accept this 2 here either. Remember what I've mentioned before. That 2 is me putting it in, right? But it's the norm that when you don't write a number here, that means it is the square root. Cool? Awesome. Let's look at number 2. Now, number 2. I have this parenthesis, and this parenthesis is to the power of 4, which means I have 4 of those parentheses, right? But the root is 8, which means I need 8 of a kind to take 1 out. So clearly I can't take 1 out. But let's talk about simplifying it a different way. Just like we did over here, correct? Let's identify the base. What's the base? Good. Y plus 1. And that is in parentheses. Now what was the power? 4. What was the root? 8. So couldn't I write this to the power to the exponent of 4/8? I sure can. And can't I also simplify now that exponent? Yes, I can. I can simplify it to the quantity, right? That's the parenthesis of y plus 1 to the 1/2 power. Now, can I simplify it any further? No, because I certainly don't know y plus 1 to the 1/2. I don't know the square root of y plus 1. Just like I didn't know the square root of a. So, if they want it left as the exponent, there it is. But if they want it turned back into a radical, then you would simply write y plus 1 underneath it. And no, you don't need the parentheses. Remember what I mentioned, the 2, when it's not there, or when a number is not here, that automatically represents the square root, right? Okay, how about number 3? Yeah, I have got a multiplication problem under here, don't I? So do I have to keep them together? No, I can look at them separately, which means I'm dealing with the 12th root of a to the power of 8, and I'm also dealing with the 12th root of b to the power of 4. And if I talk about simplifying, I could write this as a to the what exponent? Good. 8 over 12. Power over root. What does this look like when we simplify? Because you can reduce the 8/12 to what? Good. 2 over 3. Got it. What about this b? Yeah, you can rewrite it as b to the exponent, that's right, 4/12, which can be reduced to b to the exponent of 1/3. Agreed? Okay, so now let's think about this. Both of them have the same root, the cubed root, don't they? So I could leave this as a to the 2/3 times b to the 1/3. That's fine if they want the exponent, but if they want the radical, you're going to have to rewrite this as which root? Good, the cubed root. Gratefully, they both have the same root. And a is to the power of 2, and b is just b to the 1st. So this is what it would look like as a radical. Good? Awesome. How are we doing? Is this making sense? Cool. Let's look at number 4. So, this looks like 4 to the 1/6 power. And you're like, well, I can't simplify that exponent. I agree you can't simplify that exponent. But you know, 4 is not a prime number, is it? 4 can actually be rewritten as 2 to the power of 2. Isn't that 4? And that's still to the power of 1/6. Remember those rules we went over just a few minutes ago? What do I do between these exponents? Yeah, I multiply them. So this would be 2 to the power of 2 over 6. Now that I can reduce, can't I? What does it look like? 2 to the 1/3 power. Or exponent, I should say. Which means if they want the radical, you would be writing the cubed root of 2. If they want the exponent, then there it is. Does that make sense? Cool. So being able to switch between radicals and exponents is important because sometimes it can help you simplify in the exponent form what you couldn't simplify in the radical form. So stay tuned. Got some more problems. Okay, so let's look at this 5th example. They're asking us to multiply these two radicals, right? Well, remember from the past, are you allowed to multiply radicals that do not have the same root? This is a cubed root, this is a 5th root. Can you multiply when they're not the same? No, you can't. So, how is another way, or what is another way that we can tackle this multiplying of radicals that are not the same root? Yeah, I think I heard some of you say it. Couldn't we do like we did just a few minutes ago? Couldn't we turn these into exponents? Grand idea. So let's do that, shall we? So the y, the first y, the cubed root of y, this would be written as y to the, good, 1/3. And you're multiplying it by, how do you rewrite the second one? What would the exponent be? Remember, power over root. Good. 2/5. All right, that's a little nicer looking, right? I don't have that root symbol in there to get in my way. Now, I'm multiplying the exact same bases, right? Okay, so when I'm multiplying the exact same bases, what do I get to do to the exponents? Yeah, remember a few moments ago, right? We get to add exponents, don't we? But you can only add exponents, or pardon me, you can only add these exponents. Because they're fractions, you can only add them if the denominators are the same. Excellent. So in reality, one of the first things I've got to do right now is I need to add 1/3 plus 2/5. Common denominator, 15. Good, which means the 1/3 turns into 5/15. And you're like, how'd you do that? You got to remember, I had to multiply the 3 by a 5, which means the numerator gets multiplied by the 5, right? Same with this one. This 5 has to get multiplied by 3 to make it a 15, which means the 2 also gets multiplied by a 3. So I'm adding it to 6/15, which gives me 11/15, doesn't it? Which means I have y to the 11/15 exponent. Cool? Awesome. Now, if they want it left in exponent form, there we are. But if they want to make it back into the radical form, what's the root? Good, 15, so I have a 15 out here. What goes underneath? Yeah, y to the power of 11. Good? Okay, let's look at this one. Same thing, I'm dividing now, but the roots are different, right? That's a 3, that's a 4, they're different. So what should we do? Yeah, why don't we try tackling it this way? Why don't we turn these radicals into exponents instead? So, the top one, the b on the top, b to the what? Power over root, remember? Good, 2/3. What about the bottom b? Because that's a base, right? Power over root. Yeah, the power is 1, so that's a 1/4. Good. Well, again, it looks a lot nicer than dealing with the root symbol. Okay, so remember those rules of exponents. The bases are the same. Over here, I was multiplying the same bases, so we got to add exponents. But over here, when I'm dividing the same bases, what do you do to those exponents? Good, you subtract them. But remember, our brain likes to subtract the larger one from the smaller one. So since these are fractions, since our exponents are fractions, what do we do first? Good, let's get a common denominator. So what's a common denominator between a 3 and a 4? Yeah, 12. So if I change this into a 12, I have to multiply top and bottom by 4. Good, that makes it 8/12. And the bottom one, if I change this to a denominator of 12, top and bottom get multiplied by 3, which would make it 3/12. Okay, now I know the order in which I'm supposed to subtract. I'm going to take the top one minus the bottom one, right? So my leftovers go in the numerator. And I have 8/12 minus 3/12, which would give us 5/12. And I can't reduce that. If they want it left as an exponent, there it is. But if they want you to rewrite it with a radical, what's my root? Good, the 12th root of what? B to the power of 5. Excellent. How are we doing? Is this making sense? Cool. Hang in there. Got some more examples for us. Okay, we're back. Look at problem number 7. We're multiplying radicals. The roots are different, so what should we do? Yeah, let's change them into exponents, shall we? So this b is to the, good, 1/3 exponent. And you're multiplying it by, Yeah, what's my base on that second radical here? Yeah, the base is 4a because the whole thing is underneath the root symbol, right? So make certain that you put 4a in the parentheses, because what's the exponent on the 4a? Yeah, 1 over 5. With me? Okay. Now, here's the deal, right? We want these. You're like, wait, I can't multiply the bases. They're not the same. That's true. Those are not the same. However, let's think about this. If they want us to rewrite this answer, to simplify it, right, but write it as one radical, I am definitely going to need to have a what here? A common denominator. So let's just keep on that track of getting a common denominator and let's see where it takes us. So what's the common denominator between a 3 and a 5? Good, 15. So what does this 1/3 become? Excellent, 5 over 15. And what does the exponent of the 4a become? Good, 3 over 15, right? Okay, now notice this is a 15th root, isn't it? So I have the 15th root of b to the power of 5. But this is also a 15th root, isn't it? So I can write it under the same root, multiply this b to the 5th power by, yes, 4a quantity to the power of 3. Since both of them have the same denominator, they're both the same root. Cool? Okay. Can we simplify what's under that root right now? Well, yeah, I've got those parentheses to the power of 3. So couldn't I figure out what 4a, the quantity, is to the power of 3? Good. So I still have the 15th root, b to the power of 5 times, yeah, you're going to have 4 to the power of 3 and a to the power of 3, aren't you? Both of them get to the power of 3 because both of them in the parentheses were to the 3rd power, right? Okay. So, still have the 15th root, b to the power of 5. What's 4 cubed? Get off the calculators, come on. Good, 64. And then a to the power of 3. Which means the final answer would be rewritten as the 15th root of 64, a cubed, b to the 5th. They'll put the number first and then they'll put the variables in alphabetical order. So I wrote every one of these steps out because I know some of you are going to have to write all those steps, you know. I recommend it, especially when you're learning this new stuff. Write all the steps out. It really didn't take us that long to write it out. And when you write everything out, you can see it clearly what you've got to do next. Good on the problem number 7? Okay, so let's look at problem number 8. Again, I've got 2 radicals. The roots are not the same. So, yes, let's rewrite this as 5 to the 1 over 3 multiplied by 2 to the 1/2. Remember, even though you don't see it, that's a square root, isn't it? Okay, so this problem kind of looks like this one. The bases aren't the same. But remember, since the exponents are fractions, let's get those roots the same, shall we? So what's a common denominator between a 3 and a 2? Good, 6, which means we'll have 5 to the 2 over 6, and 2 will be to the 3 over 6. Good. Now check this out. The 5, isn't that the 6th root? So I have the 6th root of 5 to the power of 2, don't I? But look at the base of 2. Isn't it also a 6th root here? So I'm going to write it under the same 6th root, and this is going to be 2 to the power of 3. Excellent. All right, so we can simplify 5 to the 2nd, can't we? Yeah, that's 25. And 2 to the 3rd? Good, it's 8. So 8 times 25. Stay off the calculators. Think of 8 quarters. 8 quarters is how much money? There you go, 200. So these two problems are very good examples of what to do when the bases are not the same. I'm still going to follow the pattern of, hey, let's get these radicals into exponent form. Let's get the denominators the same and see where we can go from there. Cool? Okay, hang in there. Got some more examples for us. Okay, let's look at number 9. Well, look at there. I don't see any radicals. I already see them as exponents. So this is really good. We have saved a step of work, haven't we? Okay, so now the bases are the same. What do I get to do with those exponents? Good, I get to add them, which means, oh, and gratefully, look at that. The denominators are the same even. Yay! Wow, this problem is really nice to us. So 2/5 minus 7/5, what do we get? Yeah, x to the negative 5 over 5. Oh, well, that reduces. What does it reduce to? X to the negative first power. Excellent. Now I'm going to tell you right now, they're not going to want you to leave an answer with a negative exponent. You're going to have to rewrite it so it doesn't have a negative exponent, which means in this case, where does the x belong? Belongs on the bottom. So this is going to be written as x to the power of 1 on the bottom. And on the top, yeah, there's that imaginary 1 sitting out front, remember? So in this case, your answer is just 1 over x. Cool? Good. Let's look at number 10. So on number 10, well, the bases are the same, aren't they? So here's the thing. Be very careful on number 10. Because most people would think of doing 3 times 3 first. No. Because when you are multiplying the same bases, we get to add the exponents, don't we? Just like we did on problem number 9. So what takes precedence? Exponents or multiplication? According to the order of operations, which do we do first? Exponents or multiplication? Exponents go first. So we have got to tackle these exponents. And since we're multiplying the same bases, what do we do with the exponents? We add them. Yes. Now, these exponents are both fractions. In order to add fractions, what do you need to have? A common denominator. Are the denominators the same? No, they're not. So, we're going to rewrite it. So, what's a common denominator between a 4 and an 8? Good, 8. Which means the 1/4 becomes 2 over 8, and I'm still multiplying it by 3 to the 3 over 8. And now what do we get to do? We get to add them. So we get 3 to the 5 over 8th power. And if they want it left as an exponent, then there it is. But if they want to write it as a radical, then you have the 8th root, don't you? Of 3 to the power of 5, which means you would have to figure out 3 to the power of 5. I know, you're on your calculators. So, what'd you get? Good, I got the same thing, 243. Cool? So watch the directions. If the directions say write with exponents, then here you go. But if they say rewrite it with a radical, then here you go. So just watch your directions. Good? Okay, number 11. Wow, lots of stuff going on here, right? So you know one of the things that I see that's kind of bugging me is that negative exponent. That negative exponent has this a sitting on the top. But does this a belong on the top since it has a negative exponent? Nope. Where does it belong? On the bottom. So, first thing I'm going to do is I'm going to rewrite this problem. Before I do any work, I'm going to rewrite it. So a, 5/6 is positive power, or exponent I should say, so I'm going to leave it on top. And this a to the negative 1/2 doesn't belong on top. It belongs on the bottom. And now the power goes positive. This a to the 1/3, this 1/3 is a positive exponent, So it stays on the bottom. And now this negative. Well, you know, I'm just going to write the negative out in front. I don't need to write it on the bottom. You know as well as I do. If we have a negative on the denominator, we usually write it out front, don't we? Cool. Okay, so here we go. I have a to the 5/6 on top, and on the bottom is a to the 1/3 times a to the 1/2. What should we do first? Yes, I agree. Let's first deal with this denominator. I am adding the 1/3 and the 1/2, aren't I? Because the bases are the same. So, first we're going to add 1/3 plus 1/2. What do we get? Common denominator, 6. This becomes 2 over 6. This becomes 3 over 6, doesn't it? So, looks like the a on the bottom is going, so I still have the a on the top to the 5 over 6, and the a on the bottom also has the exponent of 5 over 6, doesn't it? And there's a negative out front, isn't there? Huh. Well, what happens when you divide something by itself? What happens? What goes on? Yeah, they cancel, don't they? Right? So I should be left with what? Some of you have it. Some of you are telling me a different number, so hold on. Let me show you another way also. Couldn't I also do it as a, the numerator, 5 over 6 minus the denominator, 5 over 6. Isn't this a to the power of 0? Which is, yeah, 1. But it's a negative 1 because the negative outside here. And you still could have gotten that answer from right here at this step, a negative 1. Good? Cool. Loving it. Well, these three problems were nicer to us because I didn't have to deal with radicals, did I? Okay, hang in there. Got one more problem for us. Let's take a look at this last problem. There's a lot going on in this problem, isn't there? Okay, so first things first. What hides, whoops, I forgot something. One of the things that hides the real problem are parentheses. So I suggest we always get rid of the parentheses first, and then let's see what's going on, okay? So I noticed there's a 1/8 outside of this parenthesis, and it is an exponent. So what do I do with an exponent outside the parenthesis? Yeah, I multiply it to the other exponents, don't I? Okay, so let's look and see what this looks like. So this numerator, we would have a to the negative 2 over 8 times b to the positive 3 over 8. Cool. The denominator also has parentheses, and there's an exponent outside, so I'm going to do that distribution as well. With me? Okay, so we're going to have negative 3 times a negative 1/4. Yeah, that's going to be a to the positive 3/4, and b, that's right, to the negative 1/4. Good. Parentheses are gone. Here's the problem I'm working on. It looks a lot nicer. So, the second thing I'm noticing is we have negative powers, negative exponents. And to me, negative exponents hide the real problem. I have no idea what's going on as long as there's negative exponents. So here's my recommendation. My recommendation is to move those bases that have a negative exponent, move them to where they belong. Okay? So for instance, a to the negative 2/8. Does that belong in the numerator? Good, it belongs in the denominator. So I'm going to write a to the positive 2/8 now that I moved it. B to the 3/8. That's positive, so do I move it? Nope, it stays on the top. B to the power to the exponent of 3/8. Good. A to the 3/4. That's a positive exponent, isn't it? Do I move it? No, it stays on the bottom. And this b is to the negative 1/4 exponent, and it's in the denominator. Does it stay there? Nope, it moves to the numerator. Good. Excellent. How are we doing? Are you with me? Yeah. Now, parentheses are gone, negative exponents are gone, and now I can see what I'm supposed to be doing. So it kind of looks like a two-part problem. In the numerator, I'm multiplying b to the 3/8 times b to the 1/4. So I have a numerator problem to deal with, and that is b to the 3/8 times b to the 1/4. But then I've got a denominator problem, and that looks like a to the 2/8 times a to the 3/4, right? Okay, so let's tackle these two problems. Let's do this first one. I'm multiplying the same bases. What do I do with the exponents? Good, we add them. So I'm going to have b to the 3/8 times b to the 2/8, which gives me b to the 5/8 power. Excellent. So I just found the numerator, didn't I? Sure did. So the numerator is b to the 5/8. Let's check the denominator. So, hey, I'm noticing the 2/8 will reduce to what? 1/4, which gives me the common denominator, doesn't it? Well, that was nice of them. Okay, so a to the 1/4 times a to the 3/4. Yeah, that's a to the 4/4, which is just a to the power of 1, which is just a, isn't it? So you just found your denominator. Your denominator is just a. Cool. So help me out here a second. Here's where we're at. Are these bases the same? Nope. So could I subtract the exponents? No. If they want me to leave the answer as exponents, this is it. And more than likely on this problem, they're going to say leave it as exponents. If they want it as radical, then we're going to have to do more work. But in this case, I highly doubt they're going to ask us to write the answer with radicals. This would be your final answer, given that they only want positive exponents. Good? Okay, so as always, if you need to rewind this video, make certain you pause, take notes, go over it and over it, make certain you understand the rules of exponents and how we apply them to all these problems. And I shall catch you on the